So I think I like to conclude this presentation saying that these trans-Neptunian objects very useful to understand our solar system. They are primordial objects. They are the origin of the comets, and they can keep many information of the formation of our solar system. Unfortunately, it's very difficult to observe. I think we arrive at the limit of the observation. Even with the very large telescope, with the 10 meters telescope, we cannot observe anymore because we are really at the limit of capability. But we hope with the new generation telescope, with the new generation instrument, we can still continue to have many discoveries on these objects. Thanks a lot, and sorry for this interruption.
We are asking sorry to you. Thank you very much for this very nice overview of this very interesting population with so many information that we have. And so I will start with the questions, as already told by Simone. I will give the word for people who are raising hands. So please raise hand. And I've seen that there is already one raised hand, and I will pass it to Marcelo. Marcelo, please.
Okay, thank you, Daniela. Thank you, Antonella, for this very, very nice talk. It was really great. Thank you. Okay, so I'm not from the area, but I have a curiosity. Why have the larger TNOs the highest albedos? Is there a physical reason for that?
Your voice was very... I didn't listen very well to your question. Can you repeat and put your microphone at low?
Maybe Antonella can take off the presentation.
You want to take off the presentation?
Yes, leave it like this. Okay.
Can you hear me now?
Yes.
Okay. So thank you very much, Antonella, for this very nice presentation. So I'm not from the area, but my question is the following: why have the larger TNOs the highest albedos? Is there a physical reason for that?
Why there is? Repeat. Why there is?
The larger TNOs, they have the highest albedos, no?
He is asking why the largest TNO, they have the largest albedo, the highest albedo. Is that normal?
Yes, okay. Exactly. That's
okay. This is very simple because the largest objects probably they have more internal activity in comparison of the small objects. So the largest objects have more activity. They can have, like in the big planets, internal planets, we can have a melting with activity of volcanism or something like this. In the case of this object, they can have some movement, like we say, cryovolcanism that can be created because they are very distant, so they have ice. So for this reason, we call cryovolcanism. But the largest objects can have an atmosphere, so they can have more activity from the interior. In this case, all this ice is put outside, and so the albedo became very high. While if you don't have this constant activity, with the time in the cosmic life, they have this crust that cover the surface. So if you don't have any activity from the interior, probably your ice is not in evidence because there is this alteration that creates a crust and your ice is inside but not in apparent. So this is what is hypothesized, and this is what is probably due to this kerogen or this toluene that is the results from laboratory experiment when you have methanol methane, you make irradiation and you don't see any features, the video became darker, and also the signature disappears because you form something like a cross all around the object.
Okay, thank you, Antonella.
Thank you. Next one is Guga. Guga, please open your microphone. Okay.
Hello, thank you, Antonella. This was very interesting talk. My question is, with the next generation of telescope, you expect to see smaller objects and farther away. Do you have any expectation that these smaller objects will fill in that color plot? I mean, they will have this. You expect that they will have the same colors, or you expect a new class, a new group, or different families in this?
Probably as soon as you have a new discovery, you can have a new classes, a new group. In any way, up to now, we have from flat object, from flat spectra, say those that have water ice or you don't see any feature, to very red. The very red are all those which you see the volatile, or you have this irradiation that allow them to become very red. So looking at small objects, you can have everything. You can have a results of a collision with a lot of water ice, or you can have a results of methane, of objects that keep some other volatile, or anything. So I think all is possible. Of course, this is thanks to the new discoveries.
Okay. Next, we have a question from Felipe Monteiro. Felipe is among the attendees.
Okay, can you hear me?
Yes.
Okay, thank you. Thank you, Antonella. Thank you for the nice talk. Could you talk about the binary trans-Neptunian formation? For example, if it is more common occur by capture or collisions, and how the Lucy mission can shed light on this binary, since Trojans can come from trans-Neptunian region, for example.
So the problem is that I think now binary is something very common everywhere. Before we discovered the first binary asteroids with the mission Galileo, we did is the small satellite Dactyl. But now we have binary asteroids, we have binary trans-Neptunian objects, we have binary Trojans. So the Lucy mission will give many explication about the formation of the binary, because they will give constraint on the composition. So if you have exactly the same composition, this could explain that these captured objects were already binary before, or you can have some captured objects. I think for the moment on the trans-Neptunian objects, you cannot say anything about the binary. There is many words about colors. They say the colors are primitive because we have some binary which we have the similar color, but I think is still very small, the information we have. There is a lot of discovery to do yet, and there is many things that we still do not understand. So I think we are looking around the other exoplanets, other planetary system, but we have still a lot of information in our solar system that we don't know. We don't know our frontiers. We don't know up to where we arrive. We don't know the population. We have some estimation, we have some idea, but there is a lot of things to discover and understand on the solar system.
Oh, thank you. Thank you for your answer.
Okay, the next one is Thiago. Thiago, please. Unmute.
Hello.
Hi, Thiago.
Thank you for your presentation. And my question is, what are the most important information that the study of these objects can give us about the solar system formation?
These objects are, in one sense, the planetesimals, as we say before, because they were not allowed to form a real big planet. When I mean even the biggest, like Eris or Pluto, that are 2,400 kilometers, they are still small in comparison to Jupiter, Neptune, all these big planets. And there is few that are big, but as you see, many are small. Many others are much more smaller we have not seen. So these objects are those that formed our solar system, as we call the brick of our solar system. So we have the asteroids that give information about the solar system in the interior part, because they are formed more close to the sun. But all these are objects that are more far away, in the cold regions, and then give all the information about the formation of our solar system at that distance. So they can give the constraints on the material, on the temperature, on all this input that need to make the models, because all what we know about the formation on the origin of our solar system is made by models, and this model needs constraints. And the constraints are given with the observation. If we don't put input with the observation, with the real data, we cannot have a model, we cannot have a speculation, we cannot make any theory.
Okay, thank you.
There was Alan that raised a hand, but I am not seeing him anymore. I don't know if he wants to speak. But then we go to the Marcelo. You need to open your you are muted. Yeah, the microphone.
Hi, hello.
Hi.
Listening? Oh, thank you. Sorry. Hi, Barucci. Thank you for your.
You need to speak a little louder. We are not hearing you.
Okay, let me see here. Yeah, hi.
Now it's okay.
Okay. Thank you, Barucci, for your presentation. It's after listening your presentation, it's my personal feeling that transneptunian objects are almost a new solar system, a part of us. Is incredible, so beautiful, and so many things to be discovered yet. But I have two little questions. The first question is about the you mentioned about Pluto geological activity. You mean inner core activity, or
yes, it's the inner. Now inner. This is the inner activity. This is what has been defined. Because otherwise, all this material cannot. If you look at the surface, there is all this flow, all this material, volatile, that cannot show this feature if there is not an activity from inside.
Okay, so wow, it's amazing. So in my last question is, if we were at Eridanes, do you think that we will see a similar image from our solar system, that the last picture that you have?
Of course, yes, is like I like to show these pictures. That is this one is just is not a real picture, of course. So we cannot go out of our solar system. But I think if someone see us from outside and is looking the solar system, probably, I don't know if there is all this material in the pole, because there is more concentration material in the equatorial, but we see something similar, because you see the planets are just here in the center. All this material, the Oort clouds arrive up to 50,000 astronomical units, probably 100 astronomical units or more. So we don't know which is really the limit. And of course, we have much more material because here we have only 50 astronomic units. We are speaking here of 1,000 astronomic units. So there is material everywhere. There are millions and millions of these objects, of course, of all dimensions that we don't see, especially in the North cloud.
Okay, thank you.
Okay. So I don't see any more.
Daniela, there is a question here in the question and answers by Evaldo Bezerra. I don't know if I read it or...
Please.
Yes, okay. So what motivated you to research these objects? How did your interest in this area come about?
Okay, I'm motivated to observe these objects because they were new. There was when we had the first discoveries in 1992, I think that all people were, this transformed our knowledge of the solar system, was something that we didn't know. So we are, all us as a researcher are motivated in new research, in new discoveries. So to understand the composition of these objects, we know there were asteroids, the composition of asteroids. We have no information about these objects at all. We didn't know which was the composition. We didn't know any information. So we tried to observe, and we were lucky because was the same time was the very large telescope available. So we asked for the first time, we were encouraged to observe with this large telescope. And we had many of you. I saw George Carvano, Alvaro, Daniela. We work all together in many of these characterization.
Okay, thank you. And there is George. You speak about him. He's with the right side. Please, George.
Hi, Antonella.
Hi. Ciao.
Very nice talk. Thank you. One question about the cold class of objects. They tend to be red. They tend to be a smaller spread in colors. Do you think that's because of formation? They formed from different composition, or is something related to evolution, optoevolution, collision, something like that?
This is the problem is you mean I go to the slide that show this, so you can have yes, this one. So this population, the small red, the small and the red, this one, this is the hypothesis that it could be more primordial, because the other one, if you think the hypothesis of the planet migration could have more collisions, so they have been ejected, while this object could be there without to move from a more long time. So of course this is just hypothesis, but there is less variation in these objects. So this is the hypothesis, they could be more primitive.
I see.
But of course, as you know, these are just hypotheses.
Yeah, we really don't know.
So we can discover that everything was wrong, and there are some other ideas that explain the differences between this. But what is strange that is in this classical population, this one here, in this part that is between 40 and 48, that have a small eccentricity, there is these big differences between the very small and very big objects. So
yeah, that's really interesting. So thank you, Antonella.
Okay, so since I don't see any more raised hand, the one that I've raised are still the old one that have not been put down. But so I would like to thank you, Antonella, for this very comprehensive overview of this very interesting population, very new, very interesting. And I would like also to apologize for the technical problem that we had to interrupt you, and we ran a little more than what was planned. So
yeah, I didn't realize that I was continuing to speak because as I had the big screen, I didn't see you in face, and I was continuing.
I imagine, we imagine that's why I wrote you a message by
Yeah,
internet,
I had
by
my
WhatsApp.
telephone here close to me, and I saw your message, so I tried to
That was,
help immediately.
we are very sorry for this
No,
problem.
no,
Time
don't worry.
occurred, and we hope to have you here
I hope too, Daniela. You know, I
next
want to come
next
soon.
you want to come.
But you are welcome to France also. So anytime any of
Thank
you
you.
is more than welcome here in Paris.
Thank
Okay,
you.
thank you. Bye.
Thank
Bye
you very
bye.
much. Bye bye. Ciao.
Bye.
Thank you
Bye
very
bye.
much, Antonella.
Thank you to
Bye-bye.
Very much,
everybody.
Antonella. Bye-bye.
Thanks to you. Bye.
Bye bye.
Thank you.
Bye. Okay. So here we go. O que ele era assistindo, hein, Simone?
Ainda estamos no streaming, tá?
Simone,
Ainda estamos
tem
no
que parar o
streaming.
stream lá em cima, na setinha.
Só que eu não tô como host,
Ué, quem tá como host?
o Vitor. Peraí. Vitor.